In computer networks, we are looking at chapter number 2, the physical layer. The physical layer, this is the lowermost layer. If you talk about ISO OSI layer or the TCP IP, the layer which is responsible for actual bit transmission. So we are going to discuss the reference model. Whichever reference model you choose, this physical layer is important because this physical layer, it will define, it will tell you about the electrical current, timing. There are various interfaces which we are going to talk about, through which we are transferring the bits. So these bits are sent as signals over the channels. These are the bits through, or the layer responsible is the physical layer. Now there can be multiple channels which we are going to discuss. So the properties of these physical channels, it can be UTP, it can be coax, it can be fiber optics. So it will determine the performance. It can be throughput, latency, error rate. Throughput is how faster or how much time the bits are coming out, latency, the delay or faster, error rate, how much is dropped or how much you get. We will talk about these with definitions. So there are three kinds of transmission media. Guided or wired. We'll talk about copper, coaxial cable and fiber optics. Then we will talk about the wireless, that is the terrestrial radio. So here wire we'll see, the first one. Guided or wired means we'll have some wire. The second one, there will be no wires. And finally, the satellite. Guided transmission media. So what is the purpose of the lowest layer? Physical layer. If 10 you are sending, it should go 10, that is bits. So transporting bits from one machine to another. So this transmission media or any channel relying on a proper physical cable or wire that you can touch, you can feel, are called guided transmission media. That is, source to destination bits are going and there has to be some way. The way is cable or wire. So there will be, why we are calling it as guided? Because the signal transmission, they are guided. If there is a proper wire, it is guided by that physical wire or cable. So this guided transmission media, it will be copper cable. It can be in the form of coaxial cable, the twisted pair, or it can be fiber optics. Fiber optics will use glass. We'll talk about the technology behind fiber optics. In coaxial cable and twisted pair, the central is copper cable. It's a very good conductor of the signals and the channel is very good. Bandwidth. There are various characteristics of any channel. For example, bandwidth. So this is nothing but the measure of the carrying capacity of a medium. Assume it to be a pipe. So the mouth of the pipe, the bigger or smaller, that will decide the higher and lower bandwidth. Okay. Now this bandwidth is measured in hertz. That is kilohertz, megahertz, gigahertz. Why we are calling it as hertz? Because here is a very famous German physicist, Heinrich Hertz. On his name, in the honor of great Heinrich Hertz, the bandwidth, you will see hertz, most of the places. Hertz. Okay. So this, along with bandwidth, we will be discussing other things. To transfer data from one place to another, there can be multiple ways. We have seen, in our vicinity, neighborhood, some wires or wireless. But persistent storage is a way the best way and the most known way. For example, you have a house. Now you are shifting to some other place. You will be transferring your house. Okay. So you will rent a truck. You will put your all belongings and then you will go to the other house. So in the context of communication, the persistent storage, the common ways to transport data is to write them on a persistent storage or the actual storage like magnetic or solid state storage. It can be DVDs, it can be magnetic tapes. And now we are physically transferring the data on the tape and disk to the destination machine. I'll give you an idea of calculation. I'll not go to the detail. This is from the Tanenbaum book, the famous book on networking. So the idea is that if you want to transfer the data from one place to another through various means, for example, truck. So this is the Ultrium tape and it can hold 30 terabytes. Now we would like to transfer say 800 terabytes. Terabytes means it will be 6400. One byte is 8 bit. So it becomes 6400 terabits. Now you can convert it into petabits also, 6.4 petabits. In United States, for example, anywhere you want to send some say delivery, it will be in 24 hours. Now this 6.4 petabits have to be transferred, say 24 hours take. 24 hours is 24 into 60 into 60 seconds. Now divide this 6400 terabits by the seconds, you will get 70 Gbps. So if you are transferring the data physically through a truck, say, that will be 70 Gbps. If you just have to go 1 hour, if your destination is 1 hour, it will be 1700 Gbps. Unimaginable. That is transferring. Now let us have a very brief calculation of cost effectiveness. For example, Ultrium tape has certain cost. What will be the cost of buying it and reusing it? Let us say it is say $4,000. Now say $1,000 for shipping, taking a truck, hiring a truck, and then so 4,000 plus 1,000 becomes 5,000. So 800 terabytes in $5,000. That will be just over half a cent, not even a cent, just over 0.5 cent. And that is very cheap. So the cost effectiveness and the transfer rate both is there in terms of persistent storage data communication. What is the moral of the story? What is the moral of the calculation? Never underestimate the bandwidth of a station wagon full of tapes hurling down the highway. That is, if you have a truck full of data, that is much more than any transfer rates. This is the example I am showing of Amazon Snowmobile. This is a large truck. It has thousands of hard disks. That is the persistent storage. All are connected through high-speed network inside a truck. The total capacity of this snowmobile is 100 petabytes. That is 10 to the power 5 terabytes, or you can call it as 100 million GB. You can imagine this. All is good. Only the disadvantage is the delay is poor. You see, the bandwidth and your cost effectiveness, persistent storage, excellent. But when you take this truck from one place to another, the time, transmission time and other things are computed in terms of hours and days, not in millisecond or microsecond, which is in the actual case you see in different transmission medium. Everything is good. Transmission time is too much. Twisted pairs. Twisted pairs. The name itself is suggesting all these wires are copper wire. So various applications that you use normally, accessing web, video conferencing, online gaming, they all rely on transmitting data with a very low delay. That is, you want the data to be just within blink of eyes, it should go, right? You have seen about the persistent storage truck going from one place to another with all the data. That will be in hours and days. But here, in the actual scenario, the oldest and the most common transmission media is twisted pair. Twisted pair. Because it is actually twisted. It will consist of two insulated copper wires. Let me show you here. These are two wires. They are different pairs, okay? Just think about one of them. One of them, the copper wires, and they are twisted like a helical DNA molecule. That is, we have, just consider this, two wires, insulated, you see the plastic also. So they are 1 millimeter thing around, and these wires are twisted, as I just said, together in a helical form. Just imagine DNA molecule. That is why they are twisted pairs. And these waves from this different twisted cancel out. Why we have a DNA molecule shape? Because electromagnetic waves concept is there. So wire, if they are twisted, the waves will cancel out. So the wire will radiate less effectively. And the signal being carried out in these wires are the differences voltage. We are not sending the absolute voltage between these two wires in the pair. There are four pairs you are witnessing. I am talking about one pair. Signal is carried as the difference voltage, not the actual voltage, not the absolute voltage. Why? Because the noise is there. Noise will affect both the voltages equally. That is, it will provide a very good immunity to the external noise, because this is affecting both the voltages equally. For example, 5 and 7 voltages are there in two wires. Now if noise is there, let us increment it by 1, 6 and 8, but the difference remains the same. So the noise affects the voltage through these wire, both the wire, in the similar fashion. That is, the differential remains unchanged. So you see here, there is shielded twisted pair cable, there is unshielded twisted pair cable. In the shielded twisted pair, we have a braided or foil shield. So wire and say a metal is combined to make a protective shielding, braided. And there is a foil shield also inside. But in unshielded twisted pair is just no shielding there. Just wires, and above it will be outer jacket. So we have these shielded and unshielded twisted pairs. The telephones, they are connected to the telephone company, telecom company or telco office by twisted pairs. And these wires, both the calls you are calling and even the internet, if you are using say digital subscriber line, ADSL internet, both of these go on these lines only. And these pairs can run several kilometers. You don't have to amplify the signals. You don't need to. Okay, it runs several kilometers. There will be no loss of the signal strength. When we have various twisted pair, they run in parallel. For example, coming from the office and going to some point, they are bundled together and encased in the protective sheath which you just saw. So the twisted pair, as I said, they will be used, they are used for analog also and digital information. So bandwidth depends on the thickness of the wire, that is the copper wire, and the distance traveled. What are the common varieties? There are various varieties. Mostly the category 5E cable, CAT5E cable is used. Category 5E is for enhanced. So there are various different categories here, you see. So different LAN standards may use different twisted pairs in a different way. For example, if 100 Mbps Ethernet is there, it uses two. There are 4 pairs, so it uses 2 pairs, 1 pair for each direction. Okay, 100 Mbps, 4 pairs are there, so 2 of them they are using, 1 pair for each direction. In case 1 Gbps Ethernet is there, it will use all the 4 pairs in both directions simultaneously. Now it is the duty of the receiver to find out, to figure out, to factor out the signal transmitted. Right? This is the duty of the receiver. Okay. So we are talking about twisted pairs. 100 Mbps you thought, some of them use 1 Gbps, all 4 pairs. So the duty is of receiver in this case. Now new things comes up here. What is the new thing? The links. So there can be multiple type of links. So the first which I am showing you, link that can be used in both directions at the same time. It is just like say a 2-lane road. Both the traffic on either side at the same time. This is called full duplex links. Full duplex links. The links that can be used in either direction, but only one at a time, one way at a time, like a single track railroad. These are called half duplex links. Half duplex links. And when we see the link that allow traffic only in one direction, there is no other direction allowed, like a one-way street. This is called simplex links. So in the category 7, there are different categories, right? So category 5 have replaced category 3 because category 5 has more twist per meter. So we have category 8 also. The speeds are quite higher. More than 10 Gbps means 10 Gbps CAT7 only. But the speeds are so higher. But the problem with category 8, I should not say problem. It can only be used 30 meters. So category 8 is only suitable to use in the data centers like the CDNs. Okay. So there are various cabling. Now through category 6, these wires were referred to as UTP. All the till 6, they were called as UTP, unshielded twisted pair. Why? Because they just had wires and insulators. There is no protective sheath. So if you take the contrast, category 7 onwards, they have shielding on the individual twisted pairs as well as around the entire cable. So inside these all the protective sheet you see, that is why the previous one called as unshielded. So this CAT7, if you see, shielding will do what? There are so many interference and crosstalk, external interference and crosstalk, it reduces. This shielding will reduce. Coax or coaxial cable. There is another common way or common mode of transmission medium is coaxial cable. Call it as coax. This provides a very good shielding and bandwidth if you compare it with the unshielded twisted pair. UTP against or in contrast with UTP, better shielding and bandwidth. You see this is the actual coaxial cable. So there are two kinds of coaxial cable and the kinds are mostly the distinction is historical. 50 ohm cable intended for digital transmission and then 75 ohm cable. This is for analog transmission and also the cable television. 50 ohm cable digital, 70 ohm cable analog transmission and cable transmission. Now this center you see, this coaxial cable has a very stiff, strong copper wire as the core, this one. And this is surrounded by this one as the insulating material. And this insulator is again encased by a cylindrical conductor and as a closely woven braided mesh network kind of covering. So this is braided mesh I am talking about. So the cloth, good quality cloth, and the metal, both of these. And the above is protective plastic covering, the final one, the black you see here. The outer conductor is covered in a protective plastic sheet. The bandwidth of coaxial cable is very good, up to 6 gigahertz. Many conversation can be simultaneously sent. For example, one television program occupies around 3.5 megahertz. You can assume 6 gigahertz is too high. The fiber optics is now taking over the coaxial cable in the telephone systems for long distance line. It is taking over the telephone lines for long haul distance lines. And this coax is widely used in cable television, metropolitan area networks, and high speed interconnectivity, especially to homes. Power lines. Now, power lines, how this communication, data communication, signal communication can be done? Power lines which you see overhead, they are electrical powers providing to, these are lines providing to house. Inside your house, there is electrical wiring. And this electrical wiring within your house will be distributing the power to the electrical outlets where you will plug in your various appliances. Okay, so I'm talking about this electrical wiring and power lines. So these power lines have already been used by the electrical companies. This is already being used. For example, I'll show you the X10 standard for low rate communication. For example, remote metering, in order to know how much is being used and to control the home devices. X10 standard. I'll just show you here. So the power line use were already there. So this is X10 controller, you have transceiver module, appliance module, and the lamp. So this is X10 standard. So we will try to concentrate on the electrical wiring inside the house. Very common scenario. We are not talking about power lines here. We are talking about electrical lines inside. How does it work? Power lines as the communication channel or networking. It is using electrical wires inside the home. Quite convenient to use the power lines for networking. Just simply plug in the TV and receiver into the wall like this, and now they can send and receive movies over the electrical wiring. The data signal you see here will be superimposed on a low frequency power signal. Of course, on the wire, that is you can call it as an active or a hot wire. As both the signals, they are using the wiring at the same time. Power signal, data signal. This is how power lines are used. But there is a scenario. The household electrical wiring is actually designed to distribute the power signals, not the communication signals. Right? The main duty is what? So the electrical signals, they are sent at 50 to 60 Hertz. And when we are sending it at 50 to 60 Hertz, the thing is, let me show you the world scenario. On different frequency, the electrical signals are sent. For example, 60 Hertz in America and Canada, India, Africa, most part of the world, you see, 60 Hertz. There are different voltages also. But the main thing is, electrical signals at this Hertz, the wiring will attenuate the higher frequency. Attenuate means lower the strength of the signal of the higher frequency, which are on the range of megahertz signals, which are actually required for high data rate communication. So the problem lies here. And when we turn on and off various house appliances, this also causes the data signal to bounce around this wiring. So there will be a transient current that will create an electrical noise, and this will over a wide range of frequencies. Electrical wiring or any wiring in terms of the electromagnetic waves, they will act as an antenna. So they will pick up external signals and also radiate the signals of its own. So in order to meet the regulatory requirement of, say, some government, You have to avoid the license frequencies. For example, the amateur radio bands. Can you afford it? Just avoiding these radio bands? No. So these are the scenario if you want to use the wiring for communication channel. But still I am saying it is practical to send at least 500 Mbps short distances by using the communication different schemes, techniques, technologies that resist the impaired frequencies and burst of errors. Coming to fiber optics, this we are going to see in the next discussion. Then thank you so much. Take care of yourself.